Wow, congratulations. It's good to know you made it to the second module. I hope you enjoyed the first module and then you did well in the examination. Yes, the online examination. If you did very well, bravo. But if you didn't do very well, don't worry. Just go through the module again, then you have the opportunity of rewriting the examination, and I'm sure this time you will do great. So once again, you're welcome to the second module for the upper primary class of MSI EduTech online home lesson. There's a mathematics class. In the second module, we'll be going through about 7 topics: order of operations, BODMAS, indices, and then we'll be talking about open sentences, weight, and a lot more. Today, we'll start off with the first topic in the second module, order of operations. Sure you enjoyed the class. The order of operation, BODMAS. Here is a way in which we can answer questions. For instance, you have different operations in a given question. Then there is a rule. BODMAS is like a rule to answer questions. Now, let's take what BODMAS means. We write vertically BODMAS. B stands for brackets. Brackets. O stands for off. D stands for division. Division. M stands for multiplication. A is for addition. S is for subtraction. Now, in a given question, you may have 2, 3, 4, or more different operations. So what BODMAS helps us to do is to know which part of the operation to attempt first. Let's take some examples. This is the question: 40 plus 5 in a bracket plus 30 minus 22 in another bracket divided by 9. Now, what are the operations we have in this topic? We have brackets. Yes, 2 brackets. We have multiplication and we have division. From BODMAS, remember brackets of division, multiplication, addition, and subtraction. Brackets comes first. That means we have to deal with the question in bracket first, then followed by division. Division comes next, and multiplication last from this given question. So let's treat what we have in brackets. We have 40 plus 5 and 30 minus 22. 40 plus 5 is 45. 30 minus 22 is 8. Now, it's as if we have 45 times 8 divided by 9. We've dealt with the brackets. This, what we had in the bracket, another bracket. Now we have times and division. Division comes first before multiplication. So we have to deal with this. So we do this way: 45 times 8 over 9. 8 divided by 9. So we can now do the multiplication. So 45 times 8 over 9. You have two options here. You could go directly 45 times 8 and then over 9, or 45 times 8 over 9. How many 9 can you find in 45? You can say this 45 over 1. 9 will divide 9 one time, and 9 will divide 45 5 times. So what we have left is 5 times 8, which gives us 40. Another example. The question is 1 over 3 of 51 plus 2 times 20. What are the operations we have in here? We have of, plus, and times. Of, plus, and times, multiplication. So which of the operation comes first? Of comes first from BODMAS, followed by multiplication before addition. So we need to treat of first. So we come 1 over 3 of 51. 1 over 3 of 51 is like 1 part out of 3 parts of 51. You share 51 into 3 parts and take 1 part of it. So it's a multiplication. 1 over 3 times 51. Now, how many 3 can we find in 51? 3 here 1, 3 in 5 1, and then remainder 2 in 21 7. So we have 17 here. Now we come here and say 17 plus 2 times 20. Our next operation is times. So we need to take care of the times first, the multiplication. So 2 times 20. 2 times 20. 2 times 20 is 40. So we come back to say 17 plus 40, which gives us 57. So the answer here would be 57. Let's move on to indices. Indices has to do with power. Let's take some examples. Now this is 48. We want to write 48 in index form. In index form. What do we do? Go back to 48. What are the factors of 48? What are the numbers that could divide 48? Let's start with 2. How many 2 can we find in 4? 2. And how many 2 can we find in 8? 4. Now 2 will divide 2 into 1. How many 2 can we find in 4? 2. 2 would still divide. How many 2 can we find in 12? 6. And how many 2 can we still find in 6? 3. Then, what next? 3, giving us 1. So writing this in index form, we have 48 becomes 2 times 2 times 2 times 2 times 3. 2 times 2, 4. Times 2, 8, times 2, 16, 16 times 3. So you could move this to 2 raised to power 1, 2, 3, 4. 2 raised to power 4 times 3. So 48 is still equals to 2 raised to power 4 times 3. Let's get another example. This is another question. Leaving your answer in index form, find the value of 5 squared times 3 raised to power 4 times 2 raised to power 3 times 5 raised to power 3. Looking at this question, we have 5 raised to power 2 times 3 raised to power 4 times 2 raised to power 3 times 5 raised to power 3. This is 5 raised to power 2. we have another 5 raised to power 3. So we come here to say 5 raised to power 2 plus 3 times 3 raised to power 4 times 2 raised to power 3. So 2 plus 2 is 5. So 5 raised to power 5 times 3 raised to power 4 times 2 raised to power 3. We could bring it from the smallest to the biggest, which becomes 2 raised to power 3 times 3 raised to power 4 times 5 raised to power 5. I hope you got that. Now we move on to squares and square roots. Squares and square roots. Let's treat square first. Square. Now, a square is a number you obtain when you multiply a number by itself. A square is a number obtained by multiplying a given number by itself. Let's take some examples. I want to find the square of 12. The square of 12. The square of 12 can be written as 12 square. 12 square would be 12 times 12. 12 times 12. 2 times 2, 4. 2 times 1, 2. 1 times 2, 2. 1 times 1, 1. Add them. 4. 2 plus 2, 4. And 1 plus 0, 1. So 12 square will be equals to 144. Now let's take another example. Let's find the square of 25. The square of 25. The square of 25 means 25 square. That means 25 times 25. 25 times 25. 5 times 5, 25, leaves 2. 5 times 2, 10, plus 2, 12. 2 times 5, 10, write 0, leaves 1. 2 times 2, 4, plus 1, 5. Add them together. 5 plus 0, 5. 2 plus 0, 2. 1 plus 5, 6. So we have 25 square as 625. This 625 is a perfect square. The square of 25 will be 625. Now let's go to square roots. Square roots. Square roots has the symbol square root. Now the square root is the number obtained, a number which when multiplied by itself, you know, when you multiply a number by itself, like in the case of square, we say 12 times 12 gave us 144. So when we want to find the square root of 144, that means a number exact when multiplied together would give that number. When you multiply a number by itself, gives that number. For instance, let's find the square roots of 49. The square roots of 49. The square roots of 49. We have, the question here is, what number multiplied by itself would give us 49? What number multiplied by itself would give us 49? From here we have 7, because 7 times 7 will give us 49. So the square root of 49 is 7. 49, square root of 49 is like saying square root of 7 times 7. So this is 7 square. You could say square as the opposite of square root. So the square root crosses out the square and you have 7 left. So the square root of 49 is 7. Let's take another example. We want to find the square root find the square root of 4,900. We could use a simpler method here. Square root of 4,900. Because of these two zeros, it's 4,900 is the same thing as 49 times 100. So this could be 49 times 100. We are looking for the square root of 49 times 100. So the square root of 49, the square root of 49 is 7, and the square root of 100 is 10. Square root, that means 7 times 7 will give us 49, 10 times 10 will give us 100. So the square root of 4,900 will give us 7 times 10, which is 70. So the square root of 4,900 is 70. 70 times 70 will give you 4,900. Let's take another example. We want to find the square root of 1,764. 1,764. Now, we could use a simpler method. What you need to do is find the factors of 1,764. Let's go this way. 1,764. What numbers could divide? Let's try 2. 2 in 1, not possible. 2 in 17 will give us 8. Remainder 1. Put the 1 by 6, making 16. 2 in 16, 8. How many 2 can we find in 4? 2. Now, 2 could still divide 2. How many 2 can we find in 8? 4. How many 2 can we find in 8? 4. How many 2 can we find in 2? 1. What number could divide? Let's try 3. How many 3 can we find in 4? 1. Remainder 1. Put the 1 here, becoming 14. How many 3 can we find in 14? 4. Remainder 2. Put the 2 here, becoming 21. How many 3 can we find in 21? 7. 3 could still divide this. How many 3 can we find in 14? 4. That's 3 times 4 is 12. Remainder 2. Put the 2 here, becoming 27. How many 3 can we find in 27? 9. This gives us 49. Remember 49. What number could divide 49? 7. So how many 7 can we find in 49? 7. 7 will divide 7 to give us 1. So the factors of 1,764 here is 2 times 2 times 3 times 3 times 7 times 7. So it's as though you are finding the square root of 2 times 2 times 3 times 3 times 3, 7 times 7. This is also equals to the square root of 2 times 2 is 2 square times 3 square times 7 square. So square roots, this square roots will cross out the squares. So we have 2 times 3 times 7 left. So the square root of 1,764 will be 2 times 3 times 7. 2 times 3 is 6 times 7 is 42. That means 42 times 42 will give us 1,642. 1,764. Another method we could come from here. 2 times 2 times 3 times 3 times 7 times 7. Okay, we group this in 2s and then pick one each from them. 2 times 3 times 7, which still boils down to 2 times 3 times 7, which is 42. Now I'll give you some activities to solve at home. These are the questions. Write out the squares of numbers 1 to 20. That means 1 square, 2 square, 3 square, up to 20 square. You find the squares. Number 2, find the square root of 361. What number multiplied by itself gives 361? Now, 9 times 2 plus 3 in brackets times 4. 2½ plus 3 1/4 divided by 2½ I hope you will be able to do this very easily. Thank you for participating in this class. Meet you at the next class. Thank you.